wherever you are. We're going to do some more problems with relating y equal mx plus b. So make sure you have your sheets that I gave to you in class today. Like I said before, I had to do the half sheets. I want to save paper, so you may or may not have enough room for each of these problems because we have 5 or 6 different questions that we're asking. So we're trying to ask a lot of questions with one different problem. And so just make sure you have your notebook and the sheets, side by side, so that you can just use them both if you have to. If you write small enough, you should have enough room. Alright, so let's get started. You're going to have 4 word problems, so there'll probably be different parts on the YouTube again. Okay, so we have Chiang Mai, Thailand has an elevation of 300 meters above sea level. A hot air balloon taking off from Chiang Mai rises 40 meters per minute. Okay, so we got 40 meters, or 300 meters, pardon me. So 300 meters, this is a distance. Okay, so that's your D. Alright, and then you have rises 40 meters per minute. Rises is positive, and then this is a rate. Okay, and then minutes is time. So you've got a distance, rate, and time problem here. Okay, so you need to recall your distance, rate, time formula. Okay, so recall that distance is equal to rate times time. Okay, so D equals R times T. Okay, so we need to use that for this formula, for this problem, pardon me. Okay, alright, so let's go ahead and get started on this. Write an equation to model the balloon's elevation as a function of time. Okay, now underline this, as a function of time. Okay, so the balloon's elevation as a function of time. So what that means is it's height of time. See how it says function? That's your function notation, remember. So if this says height of time, what that means is you have to figure out what's going to be your x coordinate, what's going to be your y coordinate. So if you put your x and your y, okay, time is going to be your x, so that's going to be time, and this is going to be height. So you put your time in the x coordinate spot, and your height in your y coordinate spot. Okay, so that's what this means. That's how we know where the x and y are. Okay, so we're going to write a relation, so we'll say relate. Okay, so now we're going to write a relationship to this problem. Okay, so we've got an elevation, a starting elevation, 300 meters above sea level. Okay, so this is actually our starting elevation. Okay, and then it rises, it's a positive rate, that's your slope. Okay, so again, this is your slope. Okay, related to your y equal mx plus b. Okay, so we're going to write the balloon's elevation is equal to, so this is distance, distance equals rate times time. Okay, so the balloon's elevation is your distance or your height, your rate, okay, so your rate times time, writing all of this in words first. So rate times time plus the starting elevation as well. Okay, so that's how we would find our full distance there. Okay, so if we're to write an equation, okay, my abbreviation for equation, alright, so we got, so we have to come up with our let statements first, okay? Alright, so let H equal the balloon's elevation. You have to do your let statements. You have to make sure you define your variables. And then let T equal time in minutes. Okay, so you have to know what conversions you're using. So we're using minutes here. Okay, so now we can go ahead and we can put this in a formula. Alright, so we've got H equals, my rate from the problem is 40 meters per minute. So that's 40 meters per minute. I'm going to put the units in there so you can see how they cancel out and relate that way. Okay, so then your time, so then that's going to be t minutes over 1. Okay, so then it's times t minutes. And then your minutes cancel out, then plus your starting elevation, which is 300 meters. Okay, so then all of this is really in meters, because meters plus meters is still meters, and my minutes cancel out. So this would give me my height here. Okay, so then I've got 40t plus 300, and then we just made that into parentheses because the whole thing is in meters. You don't really need your parentheses there when you're going through the solving process, but you need it there when you're showing your units of meters. But from now on, we're just going to use 40t plus 300. Okay, so that's where that comes from. So this is actually part A. So that's my answer for part A. Okay, so it says write an equation to model the balloon's elevation as a function of time. So that's exactly what we did there. And then B.